Hello, my name is Dan Block, and I am the manager of the College of Engineering Control Systems Lab at the University of Illinois. In addition to those duties, I also lecture two mechatronics courses, ME 461, Computer Control of Electronic Systems, and also SE 423, just called Mechatronics. And over the last 2 years, if not more, mainly because of COVID, I did a lot of recording of my lectures, and anymore it's becoming very simple for me to record my lectures because I do it all on my computer, an overhead. And so I had a lot of recordings of my different lectures, so I thought this summer, summer 2022, that I'd put together this YouTube channel. At first, my thought is it'll be useful for students that have taken my classes, that later on in the future, if you decide to use the microcontroller, this TMS 320F379D or any of the 28X family of processors, that you may want to review some of these videos. And that's kind of my goal here first, is to just have create this YouTube channel for my students that they may have a review in the future, or to kind of get started. Maybe if I'm going a little slow for you at the beginning of the classes, because people are at different levels when they start these mechatronics courses, maybe you go ahead a little bit with these YouTube videos. I went through the YouTube my recording lectures, and took out a lot of the talk about the homework assignments and things like that, and kept these videos just really the meat of my lectures that review how do we program hardware interrupts on this microcontroller, timers, interrupts, as I just said, serial ports, the UART, the SPI, I2C, ADCs, and DACs. Those lectures, the core of programming microcontrollers. And there I thought, again, you go away for a semester, you go away from a year from this material. Maybe these lectures, this YouTube channel will help you remember the things I taught you in the class. So again, initially just for students that take, but I'm going to make this a public YouTube channel. Maybe some other people will be interested in this. These lectures will help you. That'd be great. I would like to continue this YouTube channel, probably make a different playlist where I go through examples of programming this microcontroller, maybe getting a little more advanced. Talk about, well, again, this will be coming later, but talk about DMA, talk about using multiple CPUs. This processor really kind of has 4 cores, 2 main cores, and then this core called a control language accelerator. So things like that may be coming in the future. And again, if you see this YouTube video and that's something very interesting to you, or something to be useful to you, please tell me. That would give me more encouragement to make those future videos. But again, that's kind of my goal for this, as maybe an introduction or a review with these lectures that I've put together. So these lectures are from both my ME 461 class and my SE 423 class. I kind of looked at the ones that I liked the most, and some things, like for example, talking about I2C, talking about SPI, I used some lectures from both of the semesters, from both those classes. But again, I tried to go through and get rid of the homework assignments. And so, they should be, if you took 423, the ME 461 lectures should be very familiar to you also. The order that I place these videos is pretty much the order I take when I teach during the semester. I did have to mix and match a little bit with the order, and of course it's up to you. Maybe you want to just, if you're interested in reviewing SPI serial port, you may want to jump right to the SPI lectures, because the first few lectures are quite a bit of review. What is a general purpose I/O pin? Things like that. So you may want to just jump to the topic you're interested in. So use these videos as you feel fit. As the last part of this introduction video to this YouTube channel, I'd like to show you my GitHub repository. It's public, that I will be associating with this YouTube channel. It has some of the starter projects. I'm still working on this repository to get you more parts of the F28379D processor. So the GitHub repository is here. Here's the website. You can see it right here. My username is dblockil42, and then using the F28379D for mechatronics is what I named this repository. And you'll see here I've got a lot of the developer guides and data sheets for different things we do in the classes that I teach at the University of Illinois. And that's, again, what those lectures of the YouTube YouTube channel are based on. TI also has a workshop that they use to train. It's like, this is a 3-day workshop from Texas Instruments, and I put all those in this repository, all their assignments and their lecture notes. It's nice to go through that. It's very helpful too. Also, the board. So not only do you need the launch pad for that, it's a development board for the 28379D. I've also made a breakout board. Okay, and let's go. Well, actually, let's see here. There we go. Sorry, you didn't go far enough. My README actually goes into this. This was one of my students, and this was the final project for that student. This is the launch pad from Texas Instruments, and then this green board back here is the breakout board that I designed. And it has a lot of different sensors on it, power supplies, regulators, etc. It takes 12 volts. You can plug in a 12-volt battery, things like that. And it's a little bit improved from this version. This is a little bit older, not much. But so that schematic, sorry, I went too back. That schematic and being able to print that is right here. And I use the same board, even though it's called ME461, I use the same board in ME461 and SE423. The actual Gerber files, if you want to send these off, I use the company Advanced Circuits. Their website is www.4pcb.com. That happens to be. You send them the zip file and they'll be able, no, I'm sorry, you have to zip these files together and then send that to them and they'll be able to fabricate that board for you. So if that's something you're interested in. If you have more questions about that, please ask. Okay, so this is the repository. Now, what I base all the projects on are what are called starter projects. And they're located, I put them deep into the C2000ware, mainly because that's where TI puts all their examples. So if you go in here and then device support, and then now if you go look at the full C2000ware, they would have a lot more devices. Well, on my breakout board, I also have a F28027 chip on there that you could solder if you want. But the one we're most interested in is the 379D. And then you go under examples. And actually, TI gives you both single core examples or dual core. So doing things on both of the cores. I'm planning, as I get farther into this YouTube channel, to give you some more examples on programming both CPUs. So that's coming, hopefully, as I get time. CPU 1. Okay, so on here, what I've done is these down here are all TI's examples, and feel free to check them out. They do a good job of giving you small snippets of code to get things going. What I do for my lab classes is I make these starter projects. And so there's one here, Lab Starter. There's also one SPI RAM. I put an SPI RAM chip on the breakout board so I can save data. You know, that's one thing with a microcontroller, you don't have a huge amount of RAM. The SPI isn't huge either, but still I can save quite a bit more than I can in the RAM of the microcontroller. So the two examples. I'm planning on doing more. Like I want to do a DMA starter, an FFT starter, right, to do the fast Fourier transform using a library that TI supplies. So a lot of different things I'm planning on putting there. CAN, controller area network starter. So those are coming. Right now, the main one, again, I'm kind of, you'll see this get better even just over this semester. I'm gradually adding these things to the ME461 repository that I'm working with my students this semester, fall 2022. But you would just pull this in, and I'll do that in just a second in Code Composer, and it'll give you some starter code to get going with this processor. Okay, so that's the main part of the repository. Is that lab start, at least to get you going with the labs and writing the source code. Again, I'll reference a lot of these documents in the labs. Now, that's what I also wanted to show you. So this is the repository. And as I said, my repository for the actual class is a little different than this one. This is what I'm making public. And, what I'm kind of struggling with on how to continue with this public repository is, again, remember, my main job is teaching students, and I can't put out a public repository with all the solutions to my labs, can I? So I think for now I'm going to keep this just the starter code, and if this gets out to people that aren't in the class, maybe there's some way that I can send people the solution or something like that. I don't know. We'll have to figure that one out as time continues. So where the classes and their websites are here at my College of Engineering Control Systems Lab website, where you can see we teach quite a number of different classes in here. Not all of them are based on this TI board, on the F28379D. The ones that are SE423 Mechatronics, ME461, and you may be interested in the labs with SE420, which is digital control. It uses the same board, but we don't quite get as deep. We don't talk too much about how to program a microcontroller, except for just straight C code. Not talking about registers, peripheral registers, ADCs, all that good stuff. But you could check these out. They may be helpful for you if you're looking at digital control, of course. So, for example, we talk about 461 a little bit more. Now, notice here, I'm getting my Fall 22 website ready to go. So there's a number of labs that are up here right now. I'm making small changes to these labs, and gradually over the next 3-4 weeks, I think I should have most of this populated with all the labs, if that comes up. But you notice I got Lab 1 and Project 1 for this class all ready to go. Now, because I teach the SE423 only in the spring, it's got all its documents, so how I taught it back in, and it's very close, using this very similar board, just slight changes, not much. And I got the lecture notes and homework assignments that you could go through, teaching yourself how to use this microcontroller, or reminding yourself how to use this microcontroller. And then the labs. Now remember, for SE423 and actually a little bit for ME461, they use a robot car. There's 2 different robot cars I have in my lab, small little guys. And those labs use those. So just keep that in mind, especially for mechatronics. Some things will be slightly different than the breakout board that I told you to fabricate that's sitting there in the repository. Okay, so that's that. Let's really quick, we'll get into this more. I have a lecture on what the source code is and all that, but here we go. Code Composer. We're going to launch it. Now, the first thing Code Composer looks for is a workspace. Now, if you go browse, and I have them here, and here's this using, right? This is the public repository, and then there's the workspace folder. So everything I do for Code Composer, I put everything in this workspace folder. So I select that folder and launch. Just going to show you really quick how to import that lab starter. That's how all my students get going with their first project with the Launchpad. Okay, and well, the first time you pull this up, we get into this is just getting started screen. You can do a lot of things here. You could import a new project, or here, right, import. Personally, I just kill this guy and I go and remember that project, import CCS projects. Okay, and now browse. And again, where it's deep, unfortunately, but that's where TI puts it in there. So I go back to my root folder of my repository, C2000 where, device support, 2837XD, examples, CPU1, and then we go. Here we go. Now we're looking for lab starter. And again, remember all these other ones are TI's examples. So again, very good to check out. So we select on lab starter and finish. And now it pulls in a project into your workspace. This is our workspace here with all the source code for that project. And what I always like to do is rename, because if you want to pull in another lab starter, like for lab 3, you can't do it unless you've renamed this. So maybe we'll call this lab test, whatever. We can give it any name we want besides lab starter. And then just to keep them different, each lab starter is going to have a different main C file. Well, the same name here, so I also rename the main C file, and we could just call that test main or whatever we want, or lab1 main or whatever you want to call it. And now you're ready. You can build this guy. I don't have a breadboard connected to my computer right now, a launch pad. So I can just build it, and then if I wanted to debug it, build project. It's going to build it all and tell me it's ready to download. And then you would hit the bug button if you had a launch pad connected to your USB. Also, one thing to note, the processor, the 28379D, has a lot of flash. And it has quite a bit of RAM, but not a huge amount of RAM. So you got to be a little careful. When programs start getting bigger and bigger, your program can not still run out of RAM. The reason I do this is the default JTAG that comes with the Launchpad is the basic, what's called the XDS 100 V2. And it's much quicker for it to download a RAM program than a flash program, from actually to flash. Flash, right? When you power off the system, power it back on, your program's ready to run, running out of flash. So I give you two options here. You can just switch to flash, and that's great. It'll go and compile it again. The only difference is when you hit the bug, it takes about 3 times longer for it to get the program into flash than it does for it to just put it in RAM. The problem with putting it in RAM, you shut off your Launchpad, shut off the Launchpad, and your program's gone, right? Okay, but of course you can always connect it to CodeComposer and load it again. But that's the difference. When you put it into flash, then you're ready. Say it's on a robot car, it's out in the middle of the room, you can power it on, and now your program's there, starts running without CodeComposer. That's the idea with flash. So you can switch between those two right here at the hammer. So in other words, when you're debugging, it's always nice to run out of RAM. Also, you can use more breakpoints. Remember, breaks are breaks in your code. With flash, you're limited to, I think, 2 hardware breakpoints. With RAM, you can put them anywhere, which is kind of nice. So that's another reason to debug. But again, if your program gets bigger and bigger, it won't fit all in RAM. So just something to keep in mind. Okay, well, that's a good introduction.